and we are going to start with our class. And right now I'm starting recording our class because now everything that I'm going to put here is going to be important for your consideration to put on the project. Okay, so what I'm going to do today, today I'm going to start with an example showing you all the steps you need to pass through in order to complete the objective of the exercise for this test. So let's talk about what will be the objective. The main objective of our class will be to go from a standard form and this is going to make more sense when I start identifying all the details and showing all the details, okay? But right now we are going from standard form to factor form. Okay, what do I mean by standard form and factor form? Okay, so now we are going to start seeing polynomials. Polynomials, this is an example of a polynomial. Okay, so we have a polynomial. This polynomial is not the true standard form because it's the simplified form. But let's take this as, for the moment, the representation of the standard form of this polynomial. Okay, so what do we want, or what do I mean by the factor form? Okay, so we have the standard form here, SS, and I want to write this in the factor form. But what is that? So let me show you how the factor form looks, and then I'm going through all the steps to show you how did I get to the factor form. So the factor form of this polynomial is the following: x, open parenthesis, x minus 2, closing parenthesis, open parenthesis, x minus 1 to the power of 2. We close that parenthesis and then another more set of parentheses, x plus 2. Okay, so what happened with the factor form? Well, if we multiply these three factors, we have three factors here because these set of parentheses are being multiplied with each other. If we multiply them all together, we are going to get back to the standard form or the simplified form of this polynomial. The polynomial is also a function. Okay? Alright, so you might have heard of or learned techniques to factor, for example, quadratics. We can factor by groups, we can find a common factor and we can factor it out. We can do FOIL. There's many techniques to factor, more specifically quadratic equations. Quadratic equations when the degree of the polynomial, this degree is 4. The degree of this polynomial is 4 because the highest power that is on top of the variable x is 4. So the degree is 4. But when the degree is 2, okay, we are working with a square function, we are working with a parabola. So that we call that a quadratic equation. When we are working with the quadratic equation, you might have learned about how to find the zeros of that quadratic equation by using the quadratic formula. Okay, so all those techniques that I have mentioned are we can say that are the result of what we are going to learn in test number 2, because before getting to those techniques, we are going to learn about rational zeros, how to get possible rational zero for any polynomial, the relation between the rational zeros and the factors of that polynomial, Also, we are going to learn about the complex zeros, the imaginary number, and why they are important for polynomials and why we need to learn about them. Okay? So that's the exercise start here in the standard form, and the goal is to write the factor form. So let's do that. And again, this is a complete example of what we are going to be learning. Today we are doing the introduction of polynomial. Okay? So let's do that. Let's do that exercise. Let me write again the polynomial here. Okay, we have a polynomial, and we want to write it in the polynomial in its factor form. So there is no common factor that we can take from all the terms that we have here. We have 1, 2, 3, 4 terms. 1, 2, 3, 4, 5 terms. We have a constant term, and then the other 4 contain a variable, the variable x. So there is no common factor to factor out. I don't see how we can do factor by group, and the degree and the power that we are working with is 4. So yeah, we don't have those techniques to break down into parts this polynomial and find the factor form in a more straightforward way. Okay, so we need to go through all the steps. So first, we are going to list all possible rational zeros. Okay, list all possible rational zeros. That is going to be our first step. Okay, rational zeros we are going to talk more in depth later. Okay, but this is just a preview of what we are going to be learning and doing with our exercises. Okay, so how do we get the list of all possible rational zeros? So there are two important values that we need to take into consideration. That value are the constant term. The constant term is the last one here on the right. It doesn't contain a variable, that is why it's the constant term. So that number and the coefficient of the leading term. The leading term is the term with the highest power. So we have the leading term here, but the coefficient, it is missing because it is just 1. And when we are working with multiplication, if the number is 1, we omit it because it doesn't have an effect on the multiplication or the product. Okay, but those two numbers are important. Okay, so what are we going to do here? So we are going to name 4, or we are going to represent the value of 4, because what we are going to do is to find all the factors of 4. What are the factors? The factors are the following. If I multiply 1 times 4, that gives me 4. Okay, so the factor of 4 is 1 and 4. Okay, because 1 times 4 is 4. There is other factor of 4, that's 2. 2 times 2, if we multiply 2 times 2 together, we got 4 as well. So 2 is a factor of 4. All right. Not only the positive, we can also find -1 times -4. If we multiply them together, the negative cancel each other. So we got a positive value, right? And then the product is 4. So plus and minus, plus and minus, plus and minus. I'm going to take into consideration all the factors that make 4. That is also including the negative and the positive values of those factors. Okay, -1 times -4 is positive 4. -2 times -2 is positive 4 as well. Okay, 2 times 2 is positive 4 as well. Okay, so I'm going to represent the factors of 4 using the letter P. Using the letter Q I'm going to represent all the factors of the leading coefficient. The leading coefficient here is 1. So the only thing that we need to, the only factor of 1 are just 1 itself. 1 times 1 is 1. -1 times -1 is also 1. Okay? Okay, but now let's create the list. The list is going to be created in the following way. So we are going to again, P sub 4 and Q sub 1 are just a representation of these sets of numbers. Okay, we have set of numbers there, and they are a representation. Now, let's create the list of possible rational zeros. How am I going to create the list? Well, I'm going to start with this here is a fraction. Oh, so we are going to create rational numbers by taking one value, one entry from the P set, which is the factor of the constant term of 4, 1 over 1. Okay, that's just 1. Okay, so whenever we have Q at just 1, we just can write exactly the set of P. Okay, we don't need to do the fractions, but I'm going to do the fraction just to show the complete process. Later, when we got other exercises with leading coefficient not being 1, you will see a complete representation of how to create the combination P over Q. Okay, so the list of possible rational zeros also always carry over the plus and minus, because we are going to take into consideration those numbers. Okay, plus and minus 2 over 1 is just 2, plus and minus 2. Okay, and then plus and minus 4. Okay, P over Q is just exactly P, because Q is just positive and negative 1. Okay, so there is no change there. So these are possible rational zeros. When I say they are zero, a zero of a polynomial is a value of x that if we plug in that value into the function, the y value, the value of the function is going to be equal to 0. Okay, we do not know exactly which of these 6. We have 6 possible rational zeros. Plus minus is we are getting 2 versions of the same value, the positive and the negative value. Okay, we are not so sure if we plug in 1 into the polynomial, we are going to get 0, the value of 0, right? We are not so sure yet, but these are just candidates. This is a list of possible rational zeros. Why this is important? Because we have an infinite amount of values, right? And we are not going to test all the infinite amount of values to plug into the function, into the polynomial function, to see if they are 0. No, we are going to shrink that infinite amount of value into a possible list, and that is the possible list. Okay, now we need to test those numbers. There are many ways to test those numbers. The way that we are going to test in our class is by graph evaluation. Okay, why? Because it's the most quick, it's the method that is going to be quicker, and is going to be the method that is going to be more precise. But we can start plugging in those numbers into the function to see if we get a 0. We don't have time for doing that in this class. I'm just going to tell you the method, but I'm not going to require you to go through all that. Okay, we want to be more strategic in this summer semester, okay? All right, so I'm going to open Desmos and I'm going to show you the graph of that polynomial. Okay, so the polynomial that we have here, and this is the second step, okay? We are going to identify the first rational zero, okay? The first rational zero of this polynomial. So I'm going to our graph. See how the graph, the shape of the graph changes every time I enter a new term, okay? This is why the library of function is so important, because all those shapes are determined by the library of function. All right. So this is the graph of our polynomial. We'll put this ball. Okay. I'm going to zoom in, and this is the shape. Question: what is the meaning of the intercepts? The x-intercepts. The entire equation. That means that the y value is going to be equal to 0, right? So that is what. So that is what we are looking for. Okay, so this is the shape. This is the graph. Okay, thank you. Yes, leave. I don't need you anymore. Okay, so let me put this here. Just a moment. Let me go down. Let me write first. Let me set up this. No, I want the right color. Next step that we are going to do is identify the first rational zero. Okay, and we are doing graph evaluation. Okay. Another important thing of the polynomial is that the amount of zeros that a polynomial is going to have is going to be the same as its degree. Okay, that's a detail that later we are going to talk about more about that. Okay, but right now, what I want you to see is that we draw in Desmos the graph of this polynomial, and this polynomial shows us that it can contain 3 x-intercepts. The x-intercepts, they are x-intercepts because whenever we plug in those values into the polynomial function, the y value is going to be equal to 0. So here, the y value is equal to 0, the y value is equal to 0, and the y value is equal to 0. Okay? The y value is the value of the function. Remember, f of x is equal 1. So from the 6 possible rational zeros, we found out that we have -2 is an actual rational zero, +1 and +2 are actual rational zeros. Okay? So what we are going to do, we got the graph, and we know already all its zeros. Okay? We can know also the multiplicity, the type of multiplicity, but not the actual value of the multiplicity. Another thing that we are going to start talking later. Okay? But the graph is going to tell you, well, this polynomial has 3 x-intercepts. It means that it has 3 rational zeros, 3 different rational zeros. Okay? All right. So Yes, then 1, yes, it is a 0 of this polynomial, okay? But we knew that by looking at its graph. So we have identified the first zeros. And I like to go from left to right. So my first zeros is going to be -2. So the value of x equals -2. -2, you can see it that -2 is here. Okay? There is -2. So on step number 2, we have identified the first rational zero of the graph. And this one is going to be important because now we are going to use this rational zero, and we are going to know that, well, if x equal -2 is a rational zero of our polynomial, then we know a factor of that polynomial. So we are in the step of factoring the polynomial. So because x minus 2 is a 0, so a factor of the polynomial, let me give you the theoretical part here. So if x equal r is just a variable representing, that is a 0 of the polynomial, then there is a relationship between the 0 of the polynomial and the factor of the polynomial. So if r is a 0, then we have a linear factor of x minus 0. How do we use this with the actual value that we have? Well, we have a 0. X is equal -2, that's a 0. So we can get a linear factor of x minus, careful with the negative, -2. If we simplify this, this is going to be equal to x plus 2. Okay. Questions? Okay. So now we are going to do something very interesting. We know, and this is just a parenthesis here just to show what we are going to do with the equation. We know that if we multiply 3 times 5, right, we can get 15. So 3 and 5 are a factor of 15. What happens if we divide 15 by 3? What's going to be the value? (15 divided by 3). It is 5. Okay. So whenever we divide a value by its factor, we are going to get the other factor or the factors of that value, which is 15. See? When we are doing division, quotient, right? The remainder here is equal to 0. Because 3 is a factor of 15, so there's no remainder here. 3 exactly fits into 15 5 times, and 5 is the quotient of that division. So we are going to do this same process, but now with equations. We can do the same with equations. So here, what we are going to do is to find the first quotient of this polynomial, right? So what we are going to do is to divide the entire polynomial. Let me rewrite this. The polynomial is f of x, right? And then we are going to divide the entire polynomial by this factor, the factor that we have found, x plus 2. And then we are going to get our first quotient. We are going to get our first quotient. What is going to happen with this quotient? The degree of our polynomial the degree is 4. That means that the highest power that we got on that polynomial is 4. The factor that we found is a linear factor. That means that the highest power of that polynomial, because that's also a polynomial, is just 1. So the higher the degree, the more complicated the polynomial. So when we divide now a degree of 4 by a degree of 1, the quotient is going to have a degree of 3. So we are going to get a new polynomial, which is going to be the quotient of the division, and the degree is going to be 1 less. And this is important because the goal is to get to the quadratic equation to a degree of 2, so then we can apply the techniques that we have learned in the previous math classes. Quadratic formula, factor by grouping, or FOIL technique for factoring a quadratic equation. Okay, so that is the importance of this step. This division is to going from a higher degree to a 1 degree less, and we are going to repeat that until we get to a degree of 2. Okay, also the remainder is going to be equal to 0 because x plus 2 is an actual factor of the polynomial. Okay, the same effect that happened here when we divide 15 by 3, the quotient is exactly an entire integer. The remainder is going to be 0. Alright, so because we are working with a linear factor, so we are dividing the polynomial by a linear factor, whenever we are doing division of polynomial, we can do long division. But since we are dividing the polynomial by a linear factor, we can do synthetic division. Okay, synthetic division and long division. Now here I want to stop for a moment. I want to know, do you know how to do synthetic division or long division? Had you previously done synthetic division of polynomials? Okay. All right. So I'm going to show my entire process, the entire process for doing synthetic division. But if you haven't done synthetic division before, then we need to practice on this because this part is important. It is very easy, synthetic division, the way that we are going to do it. Okay, but it will take time and practice to get it done right. Okay. Okay. So someone remind me, maybe in the afternoon, send me an email. I need more practice with synthetic division. Okay. And anyone who wants more practice with synthetic division, just to focus on that, just send me an email later to then prepare you a few exercises just focusing on synthetic division. All right, so what we are going to do here. Let me take our polynomial. I'm going to write the polynomial entirely again. So we are dividing so this is f of x, that's our polynomial, and we are dividing it by one of its factor, which is x plus 2. Okay? So we are going to do, we could do long division or we could do synthetic division. I'm not going to do long division here. We are not going to need it for our class. So I'm going straightforward with synthetic division. So what we are going to do. Maybe just change the colors of these numbers. Okay, so we are going to take from the linear factor, okay, we are going to take that value, which is 2. So we have plus 2, but then we are going to take its opposite value. Remember that the actual 0 is x minus x is negative 2. The 0 of this polynomial is negative 2. Okay, so we are taking negative 2. Okay, from that factor we are taking its opposite value. And then on blue we have all the coefficients of the polynomial. So 1, also you need to take into consideration the sign of each coefficient. So -2, -3, 8, -4. Careful, you need to put this number in order. You know, the order of a polynomial goes from highest power to the constant term. So 4, 3, 2, 1, and then the constant term. If we are missing a term, you need to add a 0 as the coefficient there. Okay? So we have everything ready to start our synthetic division. And this is how we are going to do it. Down, we add, and then up, we multiply. You will see this is going to make more sense now with the exercise. Okay, so down we add. Okay, so we start with this number that are in this house here, from left to right. So 1. So we go down, and there's nothing here. So that means that we just got 1. Then we multiply. We are going to multiply to get a number here. But what are we going to multiply with? So 1 times this number that we have here, -2. Okay? So 1 times -2, we got -2. Again, now we go down. And now we have -2 and -2 in that line. So we are going down and the value is going to be -4. We go up and we multiply -4 times -2, that gives us +8. We go down again. -3 plus 8 is +5. We go up. Multiply 5 times -2, that gives us -10. We go down. 8 plus -10, that gives us -2. And we go up. -2 times -2, +4. And this is the most important part here, because now we are finishing with our division. If I can get the right color. We go down. And this is the value that you are looking for. 0. That last number there should be 0. If we got 0, it means that we did it right. Why do I know that we did it right? Because this 0 here is the remainder of the division. If we got a 0, then we are doing it correct. Why? Because we already knew that -2 is a 0 of the polynomial. So that means that x plus 2 is a factor of the polynomial. So whenever we divide that polynomial by its factor, the remainder is always is going to be 0. So that 0 here is what you are looking for. That 0 is going to tell you you have chosen a 0 of the polynomial. Okay? Obviously, if you have done correct decimal division, going down you add, going up you multiply. The rest of these numbers, these are the coefficients of what we are looking for, the quotient. Okay? I'm going to talk about how to get now those numbers and how to use them. Okay? But just this step is going to be important. You got a 0, the remainder is equal to 0. The last number on the right is equal to 0. You are doing great, because that means that your factor, you are dividing by an actual factor. You are dividing the polynomial by an actual factor. Okay? Any questions so far? Okay, so from this exercise, because we are going to find more quotients, I'm going to put quotient Q sub 1, okay? Because we have a degree of 4, and then this quotient is going to have a degree of 3, and then we need to repeat the process to get a degree of 2, okay? So Q sub 1 of x is going to be equal to what? So I'm going to take this number 1. I'm going to take all this number if I can grab it. Can I take it? No. Okay. No worries. I can just write them. Okay. -4. 5 and -2 in the same exact order, and then we are going to complete our polynomial. Q of x is we are going to put all the x's in the first we are going to put x's on the first coefficients. The last one, we are not going to put an x there on the right, -2, because that is going to be the constant term, and then we go by 3, power of 3, power of 2, and power of 1. We just can omit power of 1. If we have positive values like this 5, we need to add the addition operation, okay? And because we carry over the negative sign from the coefficient, that negative sign will be also the subtraction operation. So we don't need to put a minus 4, because we carry over the negative sign there. Okay, so from here, look what we got. That this last number is representing the constant term, okay, and this first value, which is 1, is representing the leading term. Okay, so now we have a polynomial of degree of 3. Let me get a sum of all this, because what we did here, let's call this cycle number 1. Cycle number 1, when we went from a degree of 4 to a degree of 3. Okay, so we took a degree of 4, and we downgraded its degree by 1 by using one of these factors. So now we are dealing with a degree of 3 instead of a degree of 4. Okay, the goal is to find all the zeros of this degree, of the first polynomial. This polynomial is our goal. Don't get confused. We are still working with this polynomial. But what we did is now that we divide by one factor, and now we are working with its quotient. And the quotient, we carry over all the zeros that remains to find. Okay? So list all possible rational zeros, identify one zero. That zero is going to be is going to give you the linear factor of that polynomial, synthetic deviation to find a quotient, a degree less, a new polynomial of a degree less. And we are going to repeat the process with this now polynomial. The polynomial that we are going to be working is with this one. So the next step will be working with Q1. I'm going to omit this because that's just 1 minus 4x squared plus 5x minus 2. Okay, we're going to start working with that. And then what we are going to do is to identify a 0 of this polynomial. Okay, so to identify a 0, what we need to do, list all possible rational zeros. Okay, so we are going up again, doing the same, but now with this guy that we have here. So so P, we start with P with the constant term. So the factor that we have is 1 and 2. So 1 times 2 is 2, negative 1 times negative 2 is 2 as well. And Q is just 1. Okay, so we have just plus and minus 1. So all the possible rational zeros are just plus minus 1 plus minus 2. We can go and do the graph evaluation for now Q sub 1 of x, but since Q of sub 1 of x is just the quotient of the division of the polynomial by the factor x plus 2, the same zeros, or the zeros that remains unidentified, well, they are identified because we saw those zeros here. Okay, because we saw all the x-intercept of the polynomial. So for sure, 1 and positive 2 are going to be zeros of that quotient. Okay? Negative 2 is not going to be a zero of that quotient because we already used negative 2 to downgrade the polynomial from degree of 4 to 3. Okay? So we have used negative 2. There are some moments that the zero will repeat, but in these scenarios, and later we are going to talk about that, about the type of zero, the multiplicity, odd or even, but this multiplicity is odd, so negative 2 we already use it. We are not going to use more, we are not going to use negative 2 on the quotient because we already use it to divide the polynomial function and to get a degree of 3 polynomial. Okay, so now we are dealing with positive 1 and positive 2, and for sure I'm going to take x equal 1 because I know that that should be a zero of our polynomial, because that polynomial, this polynomial here, is just a quotient of the original polynomial divided by its factor. So F, next step, ID the first rational zero of Q to 1 of x. And I just say that I know that x plus 1, it is a zero of that polynomial. Okay? Let's confirm that. I'm not going to look at the graph. Let's confirm that indeed 1 is a zero of that polynomial. How can I do that? Well, if 1 is factor of cube 1 of x. If x equal 1 is a zero, a rational zero of that polynomial, then x minus 1 is a factor of that polynomial. But how do I confirm, or what do I have to prove that indeed x minus 1 is a factor? Well, if I divide then the polynomial by one of the factor, its remainder needs to be equal to 0. Other than that, then x equal 1 is not a real zero of the polynomial. Okay, so this is another method to verify if a value is a rational value is actual rational zero of the polynomial. So let's do that. So what we are going to do is to divide q sub 1 of x by 1 minus x, and what we are looking for is the next quotient. See that now I'm using q sub 2, okay? Because now we are going to find another quotient. This quotient is going to have a degree of 2. So synthetic division again. I am taking first. I want to copy and paste this. I need this. So this is the polynomial. We are dividing it by x minus 1. Let's do the steps. I taking from the linear factor. I have minus 1, careful with this is minus 1, so I'm going to take the opposite value, positive 1. I'm going to then write down the coefficients of my polynomial. One, -4, +5, and -2. Careful with the negatives. Going down, I'm going to add. So 1 plus nothing is just 1. 1 times 1 is just 1. -4 plus 1 is -3. -3 plus 1 is -3. +5 plus -3 is +2. +2 times 1 is 2. And here's the fun part, because we have found a 0 in the remainder. So indeed, 1 is a 0 of that polynomial. Okay? So another method to identify a rational 0 of a polynomial. We get its factor, a linear factor from that value. We divide the polynomial, remainder is equal to 0. We are good with that. Okay? So from here, we can get the second quotient that is going to be a polynomial of degree of 2. So 1 minus 3 and 2, we put the xx on the first, we put the x on all the term, but not on the last term, which is the constant term. If we are missing an addition sign, we add the addition sign. If we carry over the negative sign, that is going to be also used as the subtraction operation. And the last thing is that we are going to put the powers in order. Now we went from 3, now the highest power is going to be 2, then the next one is going to be 1, and then the constant term. So we are now in the quadratic equation. I'm zooming out just a moment, because now this is cycle number 2. In cycle number 2, we went from a degree of 3 to a degree of 2, but now I'm going just to call it quadratic. Because now, when in the quadratic equation, we don't need to go through all those steps. We are going just to focus, we are going to use the techniques that we learned before from math previous classes. I'm saying that we learn from math previous classes, but that not necessarily through, I don't know, your math background, right? So if you have questions about that, just feel free to ask about those techniques that I mentioned. Okay. Okay, so we are dealing now with a quadratic equation, and we still need to find zeros. Okay, we need to find those zeros. If we do the factor form of the quadratic equation, we got those zeros. Remember that there's a relationship between the linear factor and the zeros for our polynomial. Okay, so if we factor the quadratic equation, we could also find the zeros. We have two methods, two techniques to do here. So next step. Factor the quadratic equation. The quadratic equation is the equation with degree of 2. So we have two techniques to use. There's one that always going to work, and there's the other one that you need to know how to use it, because it doesn't work in all the cases. We have the FOIL method, and we have the quadratic formula. Question: do you know the FOIL method? Do you know the quadratic formula? Have you previously at least worked with those methods? Okay. Okay, perfect. Great. Okay, so when we do this with FOIL, we are going to get exactly the linear factors. All right. From the linear factor, we can get the zeros. The quadratic equation, the quadratic formula is going to give us first the zeros, and then with the zero we can get the linear factors. Okay. So let's start with FOIL. So we create two sets of parentheses, okay, and then we know that the leading term is x squared. The coefficient is just 1, so we put 2x's here. Okay, so we need two numbers that we multiply, and we get what? If we two numbers that we multiply and we get what value? Two numbers that we multiply and we get 2. And then those two numbers, when we add them, we need to get -3. So what are those values? Well, -1 times -2 will give us +2 when we multiply them. When we add them together, we are going to get -3. So that is how those are the factors of that quadratic equation. If we multiply them together, we are going to get back to the standard form of the quadratic equation. Okay? From the FOIL method, we got the linear factors, the two linear factors. And from here, we can get, these are the linear factors. Let me change this color to this one. And then what I'm going to do is to write on blue. So we got the factor form. So this is the factor form of that quadratic equation. And here what we got are the linear factors. Okay? Let me rearrange this because I don't like the way. Okay, so that is what we got from the FOIL method initially. We got the linear factors and the factor following the quadratic equation, and by that the linear factors. Oh, so now how do we get the zero from the linear factor? Well, this is what we need to solve. Equal to 0. Because there is a multiplication, is at least one of these factors is 0, the entire product is 0. So we have two options, or x minus 1 is equal to 0, or x minus 2 is equal to 0. Okay? So from here we are going to get two values. And what are those values? Well, if we solve this, we got x equal to positive 1. And then we got, if we solve this, we got x equal to positive 2. We saw those values before. Where did we see those values? They are here. And you know this shape? You see this shape here of the x-intercept that the graph bounces on the x-axis? That is why we are seeing a duplicate of x equal 1 as a 0 of the polynomial. We are getting x equal 1 as a 0. We are seeing it two times, when the degree was 3 and when the degree now is 1. So the shape of this graph is going to tell us details that are important about the zeros. And here's the other one, positive 2. So we have found it. Okay? So that is using the FOIL method. With the FOIL method, we start with getting the factor form, the linear factor, and then we got the zeros. Okay. Let's see how we can solve also this part with the quadratic formula. I'm just showing you those two methods. You are going to select the method that you like the most, or the method that applies to the exercise, okay? Not, the FOIL method won't work on all the scenarios if we want to stay with integers. Quadratic formula will work with everything, also with irrational numbers as well, and complex numbers as well. Quadratic formula. So quadratic formula, let me write it here. X equals minus b plus minus b squared minus 4ac 2 times a. What is that? BAC. What do I mean? What do I mean by A, B, and C? Where those are variables, but what are the values of those numbers, A, B, and C? From where we can take the value from those numbers. Let me write here the standard form of a quadratic formula, or a quadratic equation. Okay, a quadratic equation has this form: a x squared plus b x plus c. So this is the general standard form of the quadratic equation, where a, b, and c are its coefficients. Let's compare this with what we have here. Okay, so let's identify the value of A, the value of B, and the value of C. Let's see let's try to rewrite this coefficient, this quadratic equation, q of 2x, q of 2x. Q of 2x. Or Q sub 2x. Okay, let's try to rewrite it in standard form. So the values for A, B, and C for Q sub 2x are A is equal 1, B is equal negative 3, and C is equal positive 2. With these values, now what we need to do is just to take this formula and plug in those values. So x equals minus 3 plus minus 3 squared minus 4 times 1 times 2, all these over 2 times A, which is just 1. Solving all this, we got here, remember always to follow the order operation, we got positive 3 plus minus then inside the radicand we have got 9, 4 times 1 times 2 is 8, 2 times 1 is 2, we continue working with this, plus minus square root of 1, okay, all this over 2, we'll simplify this by getting 3 plus minus 1, and what's the meaning of this? Plus minus 1. This means that we're going to get two values. We got the value with the plus and we got the value with the subtraction. One, 3 plus 1 is 4, 4 over 2 is just 2. 3 minus 1 is 2, 2 over 2 is just 1. So with the quadratic formula we got two x values. The two zeros are positive 1 and positive 2. So we got from the quadratic formula the zeros. From the zeros we can get the factors. The linear factors, to be precise. Linear factors then are going to be x minus 1, x minus 2. All this is equal to q of 2x, because that's the factor form. So those are the two methods that you are going to be using to find the zeros of the quadratic formula, of the quadratic equation. Whenever we get a polynomial down to a degree of 2, you know that you have the FOIL method or the quadratic formula. Okay? You are going to do just one. You don't need to do both for the exercises. FOIL method is the easiest one, okay? But you need to practice. You need to know how to use the FOIL method. The quadratic formula, it gets complicated because we are solving the quadratic formula and sometimes it is very tedious. These numbers are very good, okay? So we could evaluate the quadratic formula relatively easy, but other numbers are going to get not so nice. So we got to the same place, 2 and 1. 2 and 1 are the zeros of the quadratic equation. And with those also we got the linear factors. How do we know that we need now to stop, that we have found all the zeros of the initial polynomial? This polynomial is the one that we are working with. We need to find all the zeros to then to get the factor form of that polynomial. its degree is 4, so it has a maximum 4 zeros. This one in particular has 4 rational zeros. Okay, when we expand to complex zeros, then we will know how to find all the zeros for all the polynomials. But right now we are working just with rational zeros. This one example in particular has 4 rational zeros, so there's no more zeros to find here. See that we went through all the degrees, 4, 3, 2, and then we got to a linear factor. We stopped at linear factor. We don't need to find all the zeros because we already got those. Okay? All right. So let's recap. Okay? Going through all these steps. Let me go back. Let me go down, 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 down. So the polynomial that we start working with was a degree of 4, okay, and what we wanted is to go from the standard form to the factor form, right? To get to the factor form, we needed to find the rational, if I can write rational zeros. Okay, the rational zeros give us the linear factors. Okay, with the linear factor we can get to the factor form. Okay, so that is what we did. What are the rational zeros that we got? The rational zeros are, the first one that we found was -2. Then we found 1 and 1 twice. Okay, because we found 1 in the degree of 3 when we were working with the quotient of degree of 3, and when we were working with the quadratic equation. With the quadratic equation, we also found 2, the value of positive 2 as a 0. Okay. So we found this one in the degree of 4. We found this one in the degree of 3. And we found these two one more time. Right. In the degree of 2, which just is the quadratic. Okay, this has an important meaning because that number repeats. We have a multiplicity. Multiplicity. Right. Multiplicity, okay, of 2. The multiplicity of 2 is even, so the multiplicity is even. We are not going, right now we do my wonder, whoa, what does that mean? We are not getting there. This is just an example. I'm just giving you a complete example. On the later classes, lectures, then we are going to talk more deeply on each topic here, okay? So this has an important effect because, let me grab our graph. So the multiplicity of 2, we can see it here. When this graph, what it does is touches the x-axis and then goes back down. It like bounces. Okay, so that is an even multiplicity. Okay, that's an even multiplicity. this guy here appeared just 1, so that is an odd multiplicity. And you see the graph that it crosses the x-axis, okay? Again, this is just a preview. We are just in the introduction of polynomial. Then we are going to go more deeply on each detail, and then it will make more sense. From the zeros, we got the linear factors. And the linear factors are, from -2 give us +2. Remember, x minus the value, so x minus -2 is x plus 2. From here, we don't need to repeat, but I'm going to just put it twice just in a moment, and then you are going to see how we are going to simplify that. And from this one, we got x minus 2. Okay, so those are the linear factors. So let's put them all together. So this is equal to x plus 2 times x minus 1 times x minus 1 times x minus 2. I'm gonna move this because I want to zoom in. Okay, so we have the standard form on top and we have the factor form below. We need to simplify this because we have the same factor twice. So we can simplify this by adding the two exponents here, which is just 1, because since we are multiplying the exponent, they add each other, the base are equal. So that is the factor form. Okay, so from the factor form is telling us the zeros, the multiplicity of the zeros, okay, and those are important characteristics of the polynomial, and that's why we want to go from the standard form to the factor form. The factor form is an easier representation of the polynomial, and we can pick all the properties of the polynomial just from the factor form. The standard form see all those steps that we needed to do to get to the factor form. All those are based on the properties of the polynomial. Okay, in the factor form, once we understand the factor form of the polynomial, we just can see it and we can understand everything what's happening with the polynomial. Well, almost everything, but we can get an idea of where are the x-intercepts and how is the shape of the graph and the degree also of the graph. This is important here. These are 3 linear factors. So the exponent of this set of parentheses is 1, 2, and 1. Okay, remember this is an even multiplicity. This is an odd multiplicity. Odd multiplicity again. All right. If we add 1 times 2, 1 plus 2 plus 1, 1 plus 2 plus 1, what is the sum of these 3 numbers? Tell me the sum of these 3 numbers. Okay, class, I need at least you to write on the chat, what is the sum of 1 plus 2 plus 1? It is 4. And this is important because the degree of our polynomial is also 4. Okay? All what we are seeing right now is connected. And this is what we are seeing right now. This is just the representation of that polynomial. When you start like learning math, I don't I don't know if you are going to use math in your future career. Okay? This is just speaking me as a programmer and as a mathematician. This is the only thing I need to know. This is the only thing I need to see to understand this polynomial. Okay, and this has many applications. Okay, I do programming. If I want to describe a physics movement, and there's polynomial, there are functions and equations that describe the nature of the physics in our world. Okay, we can talk to the computer by this, not by putting the graph, not by doing a lot of other. Well, we can simplify math into what I just wrote here. Okay, I have simplified the polynomial in the standard form. I went through all this, its properties, to get a simplified version of that polynomial, and with that simplified version, I can use it and apply it to many other things. Okay, so that's why this is important. Not all the people are going to use it. Not all of you are going to use it in your future. I use it in my future, and I know that it is important. It is interesting also. If you love math like me, you will find this fascinating. That just by looking at this, we can understand this polynomial function. Okay. All right. So what else? How do you feel right now with this example? I want you to speak up. Okay. This test is the most complicated test in our class, and I want you to get ready for this. We are going to do a lot of algebraic work, and we are going to do a lot of abstract concepts of polynomials. It will become more mechanical and more easy. This is just an introduction. Okay. How do you feel right now? Were you able to copy everything or to follow me through the entire example? Okay. Mohammed, were you able to understand the example? I'm not asking you to know now the concepts. Were you able to follow me through the example? The same for you, Alex, Amina, Benjamin. Okay, Jean, Jordan, Salma, Timothy. Okay. Okay. So, in terms of the project, this is a very good example that goes through everything. Okay, this is a very good example. That's why I picked it. I chose the example. This is a good example for our college level, college algebra class level, okay? Because we are seeing all those properties that you need to learn. All right. So yeah, I'm gonna stop it there. Let me see. Let me check. I'm gonna stop here the recording. So because I don't think we are going to add anything more to our class, just going over questions that I might have and question about the test. Okay.